Recording's rolling. It is Wednesday, September 10. So, Projectile Lab Day. Remind you guys what we're doing before we go up there. Also, I hope you guys out with this. If you saw right, everybody has computation on their desk. Everybody has the paper. Okay, so look at that here in a minute. So here's the basic setup. In a few minutes, we're gonna head outside. We'll be on the balcony out here, or by the stairs. You guys are gonna take this launcher, aim it straight horizontal. So, guys, if you aim it straight horizontal, then the string should hang down through. Should say 0 degrees. Okay, guys, that's 0 degrees relative to what line? Relative to the horizontal. 0 degrees from the horizontal, which you would spell out if you were in the right direction. Okay. You guys remember projectile puzzles we've been doing the last few days? Those are due on Friday, but more to there. And I'll get you guys your kinematic motion quiz on Friday. So it's linear motion, projectile motion, which is the 3 kinematic formulas that we've been using over and over. That's all they're going to be. Period 7, there's supposed to be a reunification drill. We're just for this morning. So, okay, so it's a special kind of drill. There'll be like, some alarm. First, we shelter in place. We listen for the follow up. Okay, so guys, this is a special drill. You guys are going to be sent to the gym, and then your teachers each have assignments. Some of you guys will be in the gym. I'm supposed to like get in a nurse's office or something. So, all right. The idea is like if something bad happened and we had to like reunify you with your parent, I think it's hence the word reunification. All right, so look for that 7th period. Let's just go on there. Alright, so you guys have some equipment. You guys have these ball launchers. This is balls. Remind you guys how to use these. Okay, so you guys have a ramrod, so you can compress the spring. Now, guys, do you want to put the ball in first and then ramrod it, or do you want to ramrod it first and put the ball outward?
Stabbing out. And it's then
Oh, okay. You can use this one. Yeah, because I don't have so many. Yeah, I'll give you guys this one. Okay. So yeah, ramrod first. You guys listen. You guys hear it click, click. Okay. Now, if you go up to 3 clicks, do you think as a control you want to do the same number of clicks for every go? Okay. So I'm gonna recommend just going knocks on this every time because it's fine. See, that's done. Right. Then you put in the ball, and then after the ball's in there, then you pull up this lever. Pow! And then it releases and out it goes. Okay, so right there. You guys have some measuring tools. You guys have a meter stick nearby so you can measure some kind of displacement. Also,
I'm just looking at it.
Also, I have some terminals, not one for every table, but well, as many as I got in the stream, we got out there. So, guys, could you take the stick and well, it's like a wheel on a stick, right? Could you wheel us across the floor? And guess what the circumference of this wheel is? 1 meter. 1 meter. 1 meter. So every time it goes around, it should be like a little odometer. Oh, there it is. It's on the backside. It's like a little odometer here. Yeah, it gives you a counter. It gives you a counter of how many meters you've rolled.
Yeah.
There's a way to reset it. You have to figure that out. I forget. I know. Yeah, there is a way.
Put it in reverse.
You guys figure it out. Alright, so on this paper, write your name, names. So everybody just write their name on the paper, name of the paper. Okay. Now I'm just doing my escapes a bit on camera, so you guys go either way. Okay, this is let's call this.
I dropped it. I didn't know where to
Projectile Lab. Okay, so you know what's going on. When you're digging through your papers in December, get ready for the midterm, you pull this out. Oh yeah, that's right. This was a projectile lab. Okay. So I will do some of this with you guys. So question. You guys remember this 5-part write-up? Okay, so question. What is the last speed of the ball launcher? Let's say for a so you think if you change the mass of the ball, like what the ball was really, really heavy, do you think it probably wouldn't blast as fast? Yeah, intuitively, right? Okay, and then as we go on in this class, we'll make more sense of that. But yeah, intuitively. So I think we should control the mass of the ball. I got my triple beam bouncing. I know it's a terrible camera angle, but here, got what I got. Right. So here, I'm gonna get the mass of the ball. Now put this little tray right here. Okay. Actually, that barely even registered. Okay, so on the opposite side, this needle here, I'll show you guys what I'm looking at. Okay. This needle is pretty much hovering at the 0, even when I put the tray on. I can slide these sliders, and I'll probably most of you working with this one. If this ball is over 10 grams, it might be notching this one, something like that. But we're gonna see if it's less than 10 grams, then might not even affect. Okay, so put the tray on here. I'm waiting for this to even out. Yeah, okay, so this is pretty much for the zero at this point. So it is zeroed out. It is zeroed out. Okay, put the ball here. Okay, so that the whole thing just tipped like a seesaw. And let's do the slider. Okay, yeah, it looks like it's. Ooh. It's hovering right about 7 grams. I mean, maybe plus minus a little bit. Okay, the slider I moved all the way to the 7. It's at the 7 right now. That's pretty close. So we'll just call it 7 grams. Okay, 7 grams for a, I'll say 7.0 gram ball. Okay, so we got, all right, here's your question. Okay. And, measuring equipment. So, measuring the equipment. Okay. So I know I just used the scale, but if AP gave you this question, they would not expect to see, like, it wouldn't be worth a point because they would give you the mass of the ball and you can take that as a given. Right? So we'll take the mass of the ball as a given, and you can do this whole thing with just one measuring equipment. What would be a good measuring equipment? Yeah, meter stick. Yeah, guys, you can do the whole thing with meter stick. Now, if you want to, you can also include the trundle wheel. Trundle wheel. Right. I'll say and or whatever. Right. Okay. But that's not necessary. But definitely the meter stick. Like measure the height of the balcony. Okay. All right. So procedure. Okay. Now here's where there's actually different ways you could do this. So let's just brainstorm a little bit. Could you, if you want to, like blast the ball straight up vertical in the air and then measure how high the ball goes? And if you know how high it goes, that's going to correspond to some exact blast speed. Could you guys do it? Okay. In fact, I forget exactly what my quiz questions are, but I think that could be a good quiz question. If you know, guys, if you know how high the ball goes, because you can measure it, and you want to figure out the blast speed, which equation would let you solve the blast speed based on height? This one right here. Because here could be the vertical displacement of the ball right here, x. Right. The initial speed could be 0, goes away. Here's Earth gravity. And it, well, actually, one of these would be 0, right? Maybe the top speed would be 0 and the blast speed is what you're trying to solve for. Right? Gravity's pulling down, it goes some height. That could be this one, couldn't it? Okay. You can only use the top one if you're using the stopwatch. We're not going to use the stopwatch today, although calculating time might be an important middle step or a helpful middle step. Okay? It might cancel on the end, but we're not going to use the stopwatch today, which would involve the top. Okay, you guys it? Okay. You could do this. All right. You could aim the at launcher at some angle. And you can measure this angle theta and see how far does it go down range. Could you do that and figure out that way? Actually, I'm going to take this up real fast. Okay. All right. So this one's a little trick here. Did I walk through this with you guys the other day? Yeah. Okay. So if you measure, I just want you guys to see in principles, this would be solvable. If you're a real stellar student, maybe kind of figure this out. This proof, at least to this. Okay. So here's the range, how far down it goes. You can measure this with a meter stick or trundle wheel. You're allowed to know gravity from this lab. So take this as your favorite version of Earth gravity. Okay. You can measure this angle with a protractor. You're trying to solve for this blast speed. That's what V naught, right? It's the total blast speed. Okay. You could do that way. Totally. Okay. But just to make this sort of uniform, I'm going to bring us all to actually with your procedure, you are allowed to draw a diagram. In fact, that's a really effective way to communicate. Okay. You can actually draw a diagram. And then the AP grader knows right away from your picture. Okay, I see exactly what they're doing. Okay. So I'm going to set this diagram. I'll call this the blast. Okay. I'll call this height H, and I'll call this horizontal displacement D. Okay. You can call it X and Y. That's okay too. I'll call it D and H, X and Y, something like that. Okay. So here's my steps. So number one, I'm going to set up a launcher at edge of balcony and aim horizontally. Okay, so that aligns with this diagram, and we're not doing it straight up. We're not doing an angle. Right, we're all just doing this version. Keep it simple. Step 2. Here, what do you guys think would be a good step? There you go. Yeah, I like that. Yeah, that's exactly what I was looking for. Measure height of balcony with meter stick. In fact, if I'm imagining an AP grader is grading like 700 of these, he's like, oh, I don't even know if I'm alive anymore. I don't know what's going on. But he's got this checklist. I might do this. I'm like, height, meter stick, underline it. Like, bam, it really stands out. So, oh yeah, they definitely got that point. Height, meter stick. This was my grading sports. Right. What else can you measure? Or actually, what should you do next? Yeah, launch the ball. Okay, and then controls, right. And then you can measure horizontal displacement from the from the base, right? Like that D that's labeled, right? D, right? Again with the meter stick. All right, horizontal displacement, meter stick. There you go. Okay. And then there's actually one more key step I'm thinking in the main procedure, which is always worth a point, which is to do what?
Multiple.
Yeah, multiple trucks.
Interruption features. Please look at Ms. Ivy's email about junior testing this morning. Again, please look at Ms. Ivy's.
All right, we're back here. There's like retakes going today, so I checked it. I didn't see anything. Okay, so right. There's like test remake, right? So yeah, we're gonna do say repeat. Say steps 3 and 4 and average to reduce experimental error.
How? Our arms are always in the bunk.
Okay, that's pretty much the whole procedure. That's it. Right, that's all right. Look, 5 steps. That's all right. Okay. This particular experiment, you guys can tell there's not really an independent or dependent variable. You're not going to make a graph or anything like that. Right? It's just we're just trying to figure out the firing speed.
Can you bring your paper up a little bit?
Wait. Like that?
Yeah. Experiments are a thing.
Okay. All right. Let's do that. Okay. Okay. I mean, you guys can probably figure this out. I'm just some of you guys out there here. All right.
Wait, can we have to write the lab, the right on the page that is watch paragraph or can we
Yeah, pretty much what I'm doing here. Yeah, do this. All right. Okay. Next part. This is analysis. Okay. Now I will leave analysis to you guys. I'll leave analysis to you guys, and then you're going to come up with a conclusion. Right. Guys, when I'm looking for analysis, sometimes looking for graphs, but not today. Today, here I'll just write this in parentheses. I'll do equations. Okay. Now, obviously, you guys aren't. I want you guys to actually like solve some equations, right? You guys solve some equations, okay? And somewhere on this page too, I'll get you guys like a framework of a table set up. Got some columns going on. Got some rows maybe. Right. What variables could be important? I don't know how many columns you need. Maybe you need 2 columns, 3 columns, 4 columns. All right, so let's just figure that out. Okay. If you need more than 1 page of paper, you can do that. You can staple them together. If you need more than 1 page of paper. What variables and what corresponding units? Guys, can you do variables and units? Variables and units. Right. Try to measure something, calculate something. Maybe you'll measure something, you'll calculate some things, which would be more like analysis. Right. All right, I think we're ready to head outside. You guys ready to head outside? All right, so I'm going to close down this recording and we'll go in outside.